Hello friends, in this session we will be discussing about the conversion of flip-flops. Sometimes it is required to use a particular flip-flop into a circuit, but that flip-flop is not available. In such cases, with the help of combinational circuit and the available flip-flop, one can obtain the results of the desired flip-flop. The process of obtaining results of desired flip-flop from available flip-flop and combinational circuit is known as conversion of flip-flop. Let us take an example. Suppose SR flip-flop is to be converted into JK flip-flop. Available flip-flop is SR, desired flip-flop is JK. Write down the truth table of the available flip-flop with the present state Qn and the next state Qn plus 1 and determine its excitation table. It means write down the truth table of SR flip-flop. In this particular case, the truth table of SR flip-flop is. Now we have to find out the excitation table. To find the excitation table, determine the value of input for the various transitions from the present state Qn to the next value Qn plus 1 of the available flip-flop. The transitions are 0 to 0 transition, 0 to 1 transition, 1 to 0 transition, and 1 to 1 transition. Now we have to find out the excitation table. For 0 to 0 transition means Qn is 0 and Qn plus 1 is 0. Now in this particular case we are having two entries for this one 0 to 0 transition. Here the first entry and the third entry is for 0 to 0 transition. In this, if you will see here, the value of S in both the cases is 0, while the value of R in one case is 0 and the second case is 1. It means for 0 to 0 transition, the value of S must be 0 and value of R can be anything. It is shown here the value of S is 0 and value of R is don't care. For 0 to 1 transition, we are having one entry here. The value of S must be 1 and value of R must be 0. For 1 to 0 transition, again we are having one entry, this one. In this case, the value of S is 0 and the value of R is 1. For 1 to 1 transition, we are having two entries in the truth table of SR flip-flop, where the value of R is 0 in both the cases while the value of S is changing. It means for 1 to 1 transition, the value of S can be anything while the value of R should be 0. This is the excitation table of SR flip-flop, where by selecting the values from the excitation table, extend the truth table of the desired flip-flop. In this particular case, we are having a JK flip-flop as a desired flip-flop. By writing the required input values of the available flip-flop, the SR flip-flop in the present case, to get each Qn plus 1 from the corresponding Qn. This is the truth table of JK flip-flop. Now we have to enter the value of S and R. For 0 to 0 transition, we are having the value of S as 0 and R can be anything. S is 0 and R can be anything. For 0 to 1 transition, the value of S should be 1 and the value of R should be 0. For 1 to 0 transition, the value of S should be 0 and for R it should be 1. For 1 to 1 transition, the value of S can be anything and it must be 0 for R. From this table, draw the K-maps for S and R outputs by considering J, K and Qn as the inputs. For S, the K-map is drawn here. We are having a group of two number of ones, and while solving this K-map, we have obtained the expression J, Q n bar. Similarly, the K-map is drawn for the output R and the output comes out to be K, Q, N. The next step is to draw the logic circuit for this one. Now we are having a SR flip-flop which is available. Here this input is for the clock signal. Here Q is applied as one input of this AND gate. The other input is K. Here for R the input will be KQN. Similarly for S the input will be JQ bar. In this way, with the help of the combinational circuit and the available flip-flop, we can obtain the response of the desired flip-flop. This process can be implemented to convert any flip-flop into another flip-flop. The references for this discussion are Fundamentals of Digital Circuits by A. Anand Kumar and Modern Digital Electronics by R. P. Jain. Thank you.